Hello, everyone. Welcome to the third installment of Heath's series of virtual webinars. Thank you for joining, and we hope you're all safe and healthy out there during these uncertain times. My name is Brian Chambers. I'm the International Sales Rep for Heath Consultants, and today we're going to be talking to you about odorization, odor testing, and the Odorator 2 product. So let's go ahead and get started. So the outline for today's seminar, we're going to introduce our company, Heath Consultants, and then we'll talk a little bit about the history of natural gas odorization. And then we'll go into some of the safety regulations that have formed, talk a little bit about odorization theory, and then we'll go into the actual instrument itself, the Odorator 2. We'll talk about the functions and features, and then we're going to show a short demonstration video on the contents of the equipment as well as the operation of the equipment. Then I'm going to pass it over to my colleague, Steve Chansey. He's our principal engineer. He's going to discuss the Odor Seer software, which you can control the instrument configuration and also a GPS-based audit system and data. And then we'll go into a questions and answers period. So if you have any questions throughout the seminar, please enter them in the question and answer box over to the right-hand side, and we will collect all those questions and hopefully get to all of the questions at the end of the seminar. And as we have in our previous events, we will record this and send out a paper copy of the Q&A to everybody who's in attendance. So with that, let's go ahead and get started. So Heath Consultants Incorporated was established in 1933. We're a third generation family and woman-owned business with currently over 1,400 employees. We're a leading manufacturer of leak detection and locating products, and we also provide contract field services in leak detection, locating, corrosion, meter services, etc. So just to talk a little bit about the Heath sales territories, this is a list of the international and US-based sales consultants. If you have any questions or need any additional information after this seminar is done, please reach out to these people. They'd be happy to talk to you or provide you any information that you might need. I will also put the screen up at the end of the seminar so you can copy down the information in case you missed it. So odorization history. Let's discuss a little bit about why odorant was added to combustible gas systems to begin with. The picture you see here is the London School. This is in New London, Texas, and it was built in 1932 during the big oil boom that took place in Texas. Unfortunately, on March 28, 1937, tragedy struck, and natural gas leak at the school caused an explosion, killing over 295 students and faculty. The Texas legislature demanded immediate action, and what came out of this is that they determined natural gas shall be odorized with mercaptans, also known as thiols, and this led to a national regulation in 1940 for the odorization of all natural gas across the country. It also led to what's called the Engineering Registration Act at the time, and this required that any design engineering projects be led and signed off on by a certified and registered engineer by the state in which they worked. So this put a spotlight on the natural gas industry and renewed a focus on safety and liability in the industry and a focus on protecting life and property. So there have been odorant regulations that have evolved over the years, but we're going to focus on the current interpretations of those regulations. In the US, DOT 49 CFR 192-625 is the regulation that dictates odorant testing. And in Canada, it's CSA-CTA Z662. Now, other countries have adopted similar regulations, but most of them are based on these North American regulations. So let's get into CFR 192-625 in a little bit more detail. In Section A, it states that a natural odorant must odorize a pipeline at a concentration in air of 1/5 of the lower explosive limit, and that gas is readily detectable by a person with a normal sense of smell. Now let's break this regulation down a little bit. So what is lower explosive limit? So lower explosive limit is the percent in gas and air mixture that becomes explosive. So for methane, 5% gas and air is the lower explosive limit for methane. Now, natural gas can range anywhere from 4 to 5%. Obviously, most of natural gas is comprised of methane, but for all intents and purposes, we'll talk about natural gas as 5% lower explosive limit. So 1/5 LEL of that is approximately 1% gas and air. Now, when the regulation mentions readily detectable, what that means is that a person with a normal sense of smell would be prompted to take immediate action. So when they smell that gas, they know that that particular smell is the smell of a combustible gas, and they need to take action. They need to call their operator, or they need to call 911 or their first responder and provide immediate action. Now, when we get into normal sense of smell, that's a little bit more qualitative. But what this basically dictates is that the people performing the intensity test or the odor test, they need to be personnel that have been trained, qualified, and tested for odor detection. So let's get into a little bit of the factors around normal sense of smell. So personnel or operator has to always be cognizant of these factors that could impact a normal sense of smell, whether that be illness, the use of tobacco, strong cologne or perfume. Even age and gender can play a role in your ability to have a normal sense of smell. There's also a factor known as olfactory fatigue, where if you smell strong odors for a long enough time, it can desensitize the sense of smell on your nose. There's also an environmental factor called odor masking that we will discuss in a little bit more detail. So on with the regulation 192.625, let's talk about section E. Section E talks about the equipment that puts odorant into the pipeline. So what this states is that odorant must be introduced into the gas stream without wide variations in the level of odorant. And what this means is you want your entire system to be detectable at roughly the same level. You don't want one area to be over-odorized and another area to be under-odorized. So in the case of an over-odorization, you possibly don't even have a gas leak, but the odorant is so strong that the odorant leaches out of the system, and customers think that there's a gas leak when there may not be one. In the other case of under-odorization, you could possibly have a gas leak, but there's not enough odorant for the customer to smell it. So in that case, it could also be dangerous because you have undetectable leaks around you. So let's talk a little bit about natural odorants. So odorants are a sulfur-bearing compound that gives combustible gas its distinct odor. So what that means is that smell, that strong sulfur, sour, pungent smell that you get from natural gas, that's comprised of sulfur-bearing compounds. This is a list of some standard compounds that are used in natural gas and combustible gases. Now, there are actually synthetic mercaptans that are being used across the country and the world in certain applications, but today we'll focus on the natural sulfur-bearing compounds. So let's discuss briefly the factors that affect combustible gas odorization. We discussed odor masking earlier, but there are different environmental conditions and system conditions that could affect the odorant levels and also how that odorant is smelled. So you may feel or have a quantitative test that states you have enough odorant in your system, but you still may not be able to smell it. There's a principle called odor masking, where if you mix multiple odorants together or multiple mercaptans, one may mask the other. Instead of actually combining the smell, one can override the other one, actually reducing or masking the smell of the odorant. The odorant can actually also absorb into the soil or into plastic pipe, reducing its ability to be detected. So there's a lot of different environmental factors that need to be taken into consideration when you're odorizing your system. And that's why in the DOT regulations, it states that an olfactory test is required to make sure that you have enough odorant in your system. It's important that your operator or natural gas supplier has a monitoring and control system. And essentially what this means is that they're constantly looking at all the variables of the system to make sure that they have the adequate amount of odorization in different parts of their system. This could be injection rate. They're also going to want to focus on the odor intensity monitoring, sulfur analysis, which could be a mercaptan detector, or chromatograph testing. They're also going to want to focus on customer leak calls. It's important that the customer service that's taking these leak calls immediately reports those to the technicians, especially if there's a large number of leak calls coming from a particular area, because that is possibly a large leak or something systemic that's wrong with the system. It's also important to look at service reports. So areas where you've had prior leak calls, previous repairs and maintenance on a system that needs to be monitored a little bit more closely. So let's dive into 192.625 section F. And now we're getting into the equipment and what equipment is required to detect whether there's enough odorant in a system. So what this regulation states is that an operator must conduct a periodic sampling of the gas with an instrument capable of determining percent of gas in air at the level of readily detectable. And so this is where a device like the Odorator 2 comes into play. So ASTM, which is the American Society of Testing and Materials, now known as ASTM International, has basically standards that recommend methods to provide odorant testing. And there are two different methods that are outlined in ASTM. The first one is odor concentration method. And this is the most commonly used, at least in the United States, for odorant testing or sniff testing. This consists of recording two tests. One is a threshold detection level, and one is a readily detectable level. And we'll talk a little bit more detail on that as well. And then the second is an odor intensity method. Now, some utilities use both of these, some just use one or the other, but we'll go into a detail on how each of these work. So the odor concentration method is where you use the piece of equipment that has ambient air flowing through it, and you use a valve to start introducing gas from your gas system into the instrument. So once your gas and air mixture starts to mix, you use your nose to begin to smell that ambient air. Now, at the moment when you start to smell that, that ambient air change, you maybe don't know that it's natural gas. Maybe it just smells slightly different. You know that there's something different in the air. That's what we call the threshold detection level. Now, at that point, to continue the test, you would continue to introduce gas into the instrument and continue to smell. And at the point when you know that the smell that you're smelling is absolutely natural gas, that you're ready to take action, to call your operator or call your first responder, we call that readily detectable. That's, where somebody smells it and they say, aha, that is natural gas. No, no question about it. And what's important about this odor concentration method is that you want to detect the RDL, or the readily detectable level, below the 1/5 LEL limit. So somewhere usually between 0.75 and 1% gas is usually what most operators dictate, but you want it to fall somewhere below 1% gas in most cases. Now, the second method that we discussed is the odor intensity method. And now that the Odorator 2 is capable of performing both of these types of tests. So the odor intensity method is where you introduce gas into the instrument at a known quantity, or a predetermined gas and air mixture. So for this example, if your operator states, we want to do the odor intensity method at 0.8% gas and air, you would crank up the device, introduce 0.8% gas and air, and then you'd have the operator or technician smell the instrument. And at that point, they would decide, is that smell very strong? Is it readily detectable, or is it hardly detectable or absent? and they would rate that smell on a 1 to 5 scale. And this is another way to determine whether you have adequate odorization throughout your system, is by tracking the intensity of the natural gas throughout. So let's talk a little bit about how an operator would determine where and when to take their samples. So periodic sampling is based on many different factors: the pipeline status, characteristics, environmental concerns, or excuse me, environmental characteristics as well. So distribution system spread, the type of odorant you're using. Obviously, you're going to want to focus on areas where the customer density is very high consequence areas. Also, you're going to want to have a lot of prior experience with your system to know where have we had areas of trouble in the past, where have we had portions of the system that are under-odorized, portions of the system that are over-odorized, and maybe even portions of the system where they have a high leak rate. Another important factor is the gas flow rate, because obviously if you increase the flow rate, you could potentially have an increase in odor detection or odor calls. So another factor that goes into how you set up your monitoring and testing program is the test locations. It's very important that you test at the endpoints of your system. So you may have adequate odorization in some of the main areas near your odorants, your odorizer station. But as you get towards the end of your system, it's very possible that the odorant would dissipate or get absorbed. And at that point, you want to make sure to check at the endpoint so that the customers that are further towards the end of the system are also getting adequate odorization. Also, very important, as we mentioned before, the high consequence areas, the public buildings with large gatherings of people, whether that be schools, hospitals, high-rise buildings, churches, etc. It's also important to check at customer meters, and the reason is you might have adequate odorization in your distribution system, but you want to check the actual service line that runs to your customer to make sure that that odorization is traveling with the natural gas and is actually detectable either at or beyond your customer meter. So let's get into the equipment design. So this is kind of a rough electronic block diagram of how the Odorator works. So essentially, you're going to connect this piece of equipment to your natural gas or combustible gas stream. And you're going to connect it through the gas sample inlet, and that's going to pass through a gas regulator to bring the pressure down to a safe level. Then what you're going to do is you're going to open the metering valve and start to introduce that gas into a constant airstream. That gas is going to cross a mass flow sensor, which will give you a display on your PCB. Enter a blowing chamber, which is going to mix the gas and air and blow it out to an outlet port where you'll use your nose to sniff. So that's the basic block diagram of how this instrumentation works. So now let's get into the Odorator technology. So the Odorator is the first generation unit. Most of you are probably familiar with the Odorator. This device came out in the early 80s. It's a very easy to use device, very widely used amongst the industry. In fact, there's still customers out there that use the Odorator, and we still make and manufacture those. There are some drawbacks to using the original Odorator, though. It does require correction charts. What that means is that the percent gas that's on the display may not be accurate based on elevation, pressure, and other environmental characteristics. So a chart is placed on the instrument based on those characteristics, and it must be corrected and correlated to the value that's on the screen. So it adds an extra step and a little bit more complication to actually calculate that odorant test value. Also, this device does not have any configuration, nor does it have any mapping or GPS. And it also doesn't have data storage. So there were some aspects to the Odorator 1 that we really wanted to improve upon when we released the Odorator 2. So now let's get into the Odorator 2. So the Odorator 2 is an advanced odor testing device with a bunch of advanced features that were not available in the Odorator 1. I'll go through a few of those. So now we have the ability to record all locations and readings that are being tested. Also, we mentioned the correction. This is all taking place automatically within the Odorator 2. So no more correction charts, no more correlation, no more customization for each of the environmental characteristics that you might face in the field. So whether it be elevation, pressure, or temperature, these are all corrected for within the Odorator 2. The Odorator 2 also has built-in GPS, which makes for easy integration into corporate GIS and asset management systems. Another great feature of the Odorator 2 is it is intrinsically safe. So it is safe to use in hazardous locations. We also have advanced PC software for auditing, mapping, and report generation purposes, which Steve is going to cover here in a little bit. And another feature that was not in the Odorator is this now allows the customer to change their rechargeable lithium-ion battery on their own without having to send the unit back to Houston. So let me follow this up with the factory specifications. So I'm not going to go through these in a lot of detail, but I do want to focus on a few of them. We do have several models available depending on your local jurisdiction, your local regulations, which vary from state to state, country to country. So we have a few different methane models available, as well as a propane model. Also, I want to talk a little bit about the supply pressure. Within the manual, we recommend a 7-inch water column as a typical inlet pressure for the natural gas, but this device does require a maximum of 4 psig in gas inlet pressure. So that means if you are doing an odorant test on a system that is higher than 4 psig, you'll want to also carry a step-down regulator with you that can be installed in between your gas system and the Odorator 2 to make sure you bring the pressure down below 4 psig. All the rest of these specifications are available on our website, so feel free to review and go through these in more detail at your leisure. So on that note, I'm going to go through a short video tutorial about the operation of the OD2 or Odorator 2. And that's the end of our short tutorial. This video is also available on our YouTube channel, so feel free to watch that again as needed. So now what we're going to do is we're going to go through our Odor Seer software, which is also included in the Odorator 2. So what I'm going to do is I'm going to pass this along to Steve Chansey. As I mentioned, he's our principal engineer and was instrumental in the design of not only the instrument, but the software. So Steve, I'm going to go ahead and pass it on to you.
Once again, my name is Steve Chansey. I'm with Heath Engineering, and appreciate everyone's time and support of us and allowing us to make a presentation on the Odorator 2, both the instrument and also the Odor Seer software. As Brian mentioned, I'm going to be covering Odor Seer. There's going to be an overview because there is potentially a lot of information. There's not enough time, so I'm just going to do an overview of the major features and then focus primarily on the configuration window and also how to generate report files, both text files, CSV files, and JPEGs and KMLs. So let's get started. So as Brian mentioned, the Odorator 2 is a survey audit system overall. And so I thought I would provide an overall presentation of the software just by kind of an overall review of how an instrument is typically brought online, so to speak, a new instrument to put into service, commissioned to be able to take odorization test reads. So this is a quick guide, and as soon as I get it to change the screen, and this is just as a reference only during my discussion. It's by no means what has to be. It's for reference, and again, is for illustration only. So the quick guide is a typical sequence, and your sequence will most likely differ. The software, should be already installed by now. I'm not going to talk about this. This is just for reference material for the presentation itself. But of course, the software has to be installed on a Windows PC. And one thing I would like to emphasize is passwords. If the admin account has a password, please don't lose it, because if it's lost, then access to the data within Odor Seer database will be lost as well. And it can only be rebuilt, but there is no backdoor, so please store it safely or create other accounts with admin privileges. And so after the account is initially set up, I'll typically go in and actually start using the software to customize the presentation and or the instrument. And some of the options are to colorize the RDL levels. As Brian mentioned, the RDL level is required by the federal regulations. It has to be readily detectable. And to make an overview of a survey more graphical and easier to understand, make it quicker, more efficient, then the actual RDL levels can be assigned a color range. All less than 1%, of course, for a methane instrument. So it can be broken up into several ranges, and by color alone, the reading can be recognized, for that range and deemed, normal, okay, marginal, or, problematic, all by glancing at a map and looking at the colorization of the test locations. It's also suggested initially to enable the breadcrumb trail or the collection of waypoints for the survey route. It is disabled at the factory only to prevent the instrument from, waking up and recording where it is, and also, of course, the shipping and everything else. So the periodic fix data, which represents the trail, is turned off by default, and it is recommended, of course, to turn this on. And the primary reason is to support a condition where if you're taking an instrument read at a location where there's not good GPS signal at that location, such as an indoor location, then the breadcrumb trail would lend further proof that the surveyor was physically on site at that time and place and location, because the trail would show the operator arriving at the location and also, obviously leaving the location within the time frame the test was taken. So it's highly recommended to enable the breadcrumb trail. Brian mentioned the optional ROI test of relative odor intensity. That's also disabled by default, but it can be enabled, using the Odor Seer software. It is in addition to the RDL test. It is not a separate test. So if enabled, the sequence would go through the TDL, RDL, and then the relative odor intensity test as a full suite of tests. And then lastly, with the software, the IT manager or Odor Seer manager can create or import scripts which allow the configuration of the instrument to effectively be recorded in a file, and that file can be emailed or sent to other machines for updating, so it's easy to transfer settings between the Odor Seer software and the actual instruments out in the field. And of course, going through the sequence, once Odor Seer is set up and the instrument's configured, instruments used in the field to take tests and record the data. And then upon completion of the survey route and the test points, the instrument is brought back, typically the first time, through USB to connect to the instrument, even though, again, remote instruments can have their data imported through the use of files. I'll talk briefly about that here in a little while. But typically, reconnect the instrument, run Odor Seer, log in for permissions. You have to bring the data in, of course, and there's a couple of options to do that, but primarily bring the data into the instrument, both the readings and the periodic fixed data if enabled. And then from there, view and interpret the data, create maps, select readings, etc., to create reports, and also, create optionally periodic fix file. If you do have the Odor Seer remote for remote locations, the only difference is the instrument being remote. There is a separate software package called Odor Seer Remote that field operator would install on a Windows laptop or computer, and it's processes files only. There's no login. Nothing can be changed per se, but the remote operator would be able to download the information from the Odorator 2 into a file. It's encrypted, and then that file can be sent back to the Odor Seer managers, where it can be imported into the database and analyzed and maps generated, etc. So remotely, there's possibly 3 files. It's the readings file, the periodic fix if enabled, and also a script that can be both uploaded remotely and or the instrument configuration can be read into a script and sent back to Odor Seer for management and to oversee the configuration of the instrument. So again, bring in the data into Odor Seer. And it's either way, either remotely or through USB. So once in and the data's in, then that's where the tools come to use. Primarily, it's for viewing the data graphically up front, and then selecting data to create report files. And so the menu structure is 2 major categories. Of course, file support, which has to do with 2 basic ways to bring information into Odor Seer, and then export or converting selected readings or files into different file formats. And the selected file formats are CSV for Excel spreadsheets, text files, and also into KML. And on the instrument side itself, there's a Manage tab, which we'll be briefly looking at a little further, which is the Configure, but it allows functions such as creating those colorized readings and also adding users to the system, to be managed. And then lastly, there's a section on view where either the readings in an Excel style format can be looked at, or readings with a live map representing those readings can also be shown. So going into Odor Seer and after the instrument's set up, one of the first things, of course, we talked about was just setting up the configuration. So this is, manage configuration. And there's, approximately 10 fields that are selectable, of which 3 or 4 are really only modifiable practically. The rest of them are usable for defaults. Again, I mentioned that things such as the periodic fix was disabled, and this is where this would happen. So once in configuration, the sequence to bring it and also change it is within the window, and I have a window on the next slide, is you select either your instrument or a script file that contains the data, and then you read that instrument or that script file, and that brings the existing configuration information into Odor Seer so it can be viewed and modified. Then the respective fields are modified, and then that configuration is either saved locally to the instrument, or if a script was brought in, then you have the option of saving a new script to record the changes, for future use. So this is an image of the configuration page within Odor Seer. Everything is all on one page. At the top of the window is the option of either having a connected instrument or a script file, and here it's the connected instrument. Once connected, again, read the configuration. It will populate the drop-down boxes at the bottom of the window, as well as provide some real-time information about the instrument in the middle of the page. So again, from here, it's primarily just select the drop-down boxes and make the selections. And when you're all done, click configure at the bottom, and that will update a connected instrument. Again, it's highly recommended to turn on and enable the wake up and record position function, which is shown here. It shows being selected. Don't wake up when you're being charged. Otherwise, if you didn't, it would record where it was being charged. And also important, if that's enabled, is to set the time between logs of its periodic fix information. So that's just determined by the route and how long it's going to take the operator to be able to travel. It can be anywhere from a few minutes, up to an hour. It's also where a user can be assigned. So a user has to be created first, and then they'll exist in this drop-down box, and they can be clicked and selected. CalDate can be useful for scheduling the instrument to be returned for annual calibration within operation schedules. So it defaults to 1 year, and it'll alert the operator on the screen as well as the Odor Seer manager. It can be shortened to adapt again to operation schedules, but it cannot be lengthened more than 1 year. It will alert the operator. It has to acknowledge with the keypad, but the instrument will still be functional even though it would report that it's out of calibration. The RDL high alarm level will make an additional indication to alert the operator of a high odorization read, and it's adjustable all the way down from the model type to a lower value. So for a methane instrument, it starts off at 1%, but it can be adjusted lower. And then lastly, this is where the optional ROI test is enabled to allow that additional test sequence to occur. So now that we have everything configuration, we recorded data, we brought it in, it's all been imported, and now we want to use Odor Seer to process that data and do something with it. So typically, once connected, the data is imported only into the instrument for further processing. It can also be imported and saved to file, and it'll immediately just jump to the, create a file type dialog. But a typical sequence is just to import the readings and the periodic fixed data alone, and then view readings and map, which gives a high-level visual look at what the results of those readings were graphically. Again, per the colorized reads, it's very easy to tell if everything is within the company policy and compliance. If a particular group of readings or reading is of interest or an area, the map on the right can be sized with the mouse controls. It can be expanded, zoomed. Also, the map window pane itself can be enlarged by dragging the edge of the window to as large as what the window it's in is. So it can be drawn to a large scale, a small scale. It can be zoomed and panned to get the desired image. And also included in the choices are the choice of having an aerial overlay option on the image at the top of the map. And when everything is as desired for the view, then this map can be saved as a JPEG by clicking the Save Map image at the top right of the screen. It brings up a standard Windows file naming box, and select your folder and typically click Save. And that JPEG image that was shown in that window will be saved. Similarly, select readings can be reviewed and selected for the purpose of generating either a text report or a KML file. And the sequence is very similar. Once the data is imported, then the other choice is just to view readings, not view readings and map. So if you view readings, it brings up the readings that are in the Odor Seer database. Select readings can be highlighted and selected for the sake of generating a report, as shown here. That's what the blue bands are. They're standard Windows row selection features, such as left click, holding the control key down. You can randomly pick rows, or you can select blocks of rows by clicking the top and then holding the shift key down and holding the bottom. So once specific readings of interest are selected and highlighted in blue, then those readings can be exported into different file types directly. And the process is, once selected, is just to say File Export. If the choice were to originally were to select Import and Save to File, then it would immediately go over to the Export window. So this is just a different way of getting to it. It allows you more time to analyze your records and select the readings of interest. So once selected, at the tab at the Odor Seer top, just File Export, and a file save, a dialog box will open as shown here, and you'll have your choices of either saving the selected readings into either CSV, text, or KML file formats. And of course, one of the things that can be done is to generate a survey map of those locations here, showing an illustrative example of the colorized readings over a survey area. Also, for the periodic fixed data, the same desire is needed to be able to bring that information in and also be able to generate waypoints, for further mapping purposes. So the data has to be imported, as we've discussed, and it can go import and save directly to, and this dialog box will open, or again, the readings can be viewed, and you click File Export and go that route as well. Typically for periodic fix, it's going directly to the Save File option, and so once that utility is selected in Odor Seer, import and save periodic fix data. Then this window opens up and there's a sequence of approximately 4 steps that needs to take place for everything to work correctly. First thing is, is it a connected instrument or is it a script file at the top of the window? And then secondly, you have to know what your choices of periodic fix data are in the first place, because you will be interested most typically on a certain day at a certain time. So you would query the database and say list available dates under this instrument, and those available dates will appear in this date box. The date of interest needs to be highlighted as shown here in blue. And then you tell Odor Seer, okay, bring that data in for further processing. So the import and display fixed data for selected data button gets clicked, and the data will be populated in the window screen on the right. That represents all of the periodic fix values. Should they all be elected to be created a file for, then Control A or similar Windows row selection tools can be used. But the fixed data rows of interest has to be selected again, as shown here in blue, that all the columns, all the rows are selected. And so once the survey day and the specific, survey data is imported and the selected survey data is highlighted, then go back to the left on the dashboard and say export selected data to KML, and it generates a waypoint file as shown on this screen. And that can be used for further importing into other mapping and asset software, such as ArcGIS, and this can be a separate layer which shows the waypoints layered on top of the readings, which could also be layered on top of the asset map. And that's my presentation of the overview of the Odorator 2 Odor Seer software, and with focus on configuration and creating report files using Odor Seer. And I thank you very much for your time, and I'll be transferring now this back over to Brian.
Thank you, Steve. Appreciate it. So I think now we're going to, we've got a few questions, so we're going to have Vivian, our moderator, ask a few questions that we can answer over the webinar.
Thank you, Brian. Okay, so I will answer real quickly a couple of them. Yes, a copy of this event will be emailed out to all those who registered to attend. It will either go out the end of this week or first part of next week to the address that you registered with. It will also be available on Heath's YouTube channel, and it will be up there publicly, so you can refer back to it at any time and share that with colleagues that you want to share with. A video, the video that Brian showed is also currently available on our YouTube channel. So if the audio cut out on you, which I know some of it did, or if you didn't catch all of that video, it is currently available on our YouTube channel. So to some of the questions that came in via the chat, what is the max pressure for inlet on the Odorator?
So I can go ahead and answer that one. I know there was a question on what's the required pressure. There's not really a required pressure. We recommend anywhere between 7 inches water column, which is about 0.25 PSIG, all the way up to 4 PSIG. So 4 PSIG would be the max, 0.25 PSIG would be the minimum.
Okay, and then we had, do we need to log threshold readings?
I believe so, Steve, correct me if I'm wrong, but I believe even if you're not going to utilize threshold, you do still need to to acknowledge the threshold reading. You could actually open the valve up to your RDL and then just hit the read button twice, and this would just record the RDL 2 times. Is that correct, Steve?
Yes, it could. The OD2, the Odorator 2, records both the TDL and RDL primarily because of compliance to the D6273 standard for odor intensity tests. So it's just a formality of the test sequence. So again, it's just that threshold where something is starting to change, TDL, then keep going, and then once it's known to be readily identifiable as odorant and natural gas, then that's the RDL, and then that's the one that satisfies the federal requirements.
So if you are in a country or a region that doesn't require a threshold detection level, our recommendation would be just to acknowledge the threshold and then move on to the readily detectable by hitting the read button twice.
Yes, that's also doable.
Okay, so is there any calibration of the system required, or is there an auto calibration feature available in the software? If there is calibration required, where would they send it for calibration if they are inside the US or outside the US?
So I'll go ahead and take that one. Unfortunately, there is no way to field calibrate the Odorator 2 or the Odorator 1 for that matter. Currently, the only calibration station or calibration facilities that we have are within the United States and South America. So at this time, you would be required at a minimum of 12 months, a maximum of 18 months to send your instrument in for calibration to one of these 2 locations. Now, if it is important for you to have a local calibration a repair facility, we recommend that you reach out to the distributor in which you purchase the unit and work with them on reaching out to us. We have the ability to authorize additional calibration centers, but that would be up to the distributor in local regions to set up and become certified to become an authorized repair facility or calibration facility, excuse me.
Okay, a couple more questions. Can the Odorator 2 be preloaded with locations that we want to have sampled?
I'll take this one, Brian. It's on our wish list. So no, there's not a ticket system per se where the locations can be preloaded onto it, though we certainly see that as a future option and feature.
Okay, and one more. Is the raw data / readings editable in the software?
I'll take that one also. Within Odor Seer itself, it is not. Again, the intent was to have an audit system where the data was protected at all costs, and that includes, of course, any kind of editing. So the Odor Seer data itself is not editable. You have to use Odor Seer to access the data, and that's what the tools are for that I presented, bringing up the maps and also how to create the report files. So no, they're not. It's not editable within the Odor Seer database for security and audit purposes.
And I just echo onto that is if you do happen to get a bad read somewhere within the test, what you would need to do is note that down, your timestamp and your location. And once it's exported to an external system, you can at least flag that or note or even at that time change the raw data to reflect a potentially bad test. But within the software, just for audit purposes, you're not able to change it. But once you export it, you can do with it whatever you want with the data.
Okay, so we have a couple more questions coming in. I'm going to go with one more and then we'll have to kind of cut it here. If you have a question that hasn't been answered, if you stick around for a few more minutes, we have the moderators that'll stay on and try and get to your question in the chat. So is Overseer a potential app that can be loaded into our iPhones and view on site current methane readings accurately, or viewed from an office laptop for accuracy, as well as recent locations be viewed?
Yes, for the future and all the above. That's also on our roadmap to further expand the Heath portfolio of wireless communications to our survey instruments. So not at this time, but it is certainly on the feature list for the next round of upgrades on the instrument.
Okay, so thank you everyone for attending. Brian, I'll turn it over to you for last words, and we'll wrap it up.
All right, thank you, Vivian. We appreciate everybody for joining, and I know taking time out of your day means a lot to us, and we hope you got some informative details on the instrument and why this instrument is important for tracking and tracing your odorant readings. Again, thank you for joining, and like Vivian mentioned, if you have any additional questions, we will stick around and try to answer as many of them as we can in the chat. And other than that, all the Q&A will be sent out along with the video once everything is put together. So again, thanks for your time. Everybody stay safe and healthy out there, and please take care.